All right, so now this leads us to two ways of looking at a vector. There are two ways to write it. And this page right here is just a bunch of examples. Really isn't much for me to show how to do. It's just, this is two ways to write it. So, vector B, for example. Let's see here. Boom, boom. That'll work. Very strange. Does not appear to want to work. It's all right. Well, let's try this. My apologies. Does not want me to. There we go. So vector B right here. One way to look at vector B is that it is at about 18.4 degrees. So in other words, this angle here there we go, struggling with that. That this angle here is 18.4 degrees, and that the length of this vector, its magnitude in other words, is 6.3 units of some kind. But of course, we've already seen in the previous video, another way to describe that exact same vector is by giving its x component and its y component. And when we do both those things, this way right here is called magnitude angle form, for reasons that are pretty obvious. You give the magnitude of the vector, its length, 6.3 would be its magnitude, and then you give an angle. In this case, 18.4 degrees. And since the 18.4 is in the first quadrant, it's pretty self-explanatory. So that's one way to look at vector B. But another way to describe the exact same vector would be to say, and this is how we write it. We write the x component here, and we put an x next to it. Actually, we're supposed to put a little arrow on it. When they're bolded like this, that's when you're typing, that's what you do. You bold them, but if you're handwriting them, you put a little arrow above it. So this is the x component, and then plus 2 is the y component. So two ways to write the exact same vector. Now, let's take a look at vector, well, let's go with vector h. So vector h, you'll notice here, there's actually two ways you could write the magnitude angle form. In both cases, the magnitude is the same, 5.4. One way to describe it is to say its reference angle is 21.8. So what would that look like? This is vector h, right? So that means this angle is 21.8. Or, and to say that it's in the third quadrant, so they know where that is, right? Because 21.8 could be here, it could be here, it could be here. But tell them it's in the third quadrant. Or you can give it as 201.8, which is this angle from, and I'll do it in a different color, from the x-axis all the way around to there. That's the 201.8. So you can give the angle in either way. If you give a reference angle, you have to let them know what quadrant you're in. Oops. Now, the other way to describe vector h, of course, let's see if it's here. If not, we'll do it ourselves. All right, so what, I don't see it. So what is vector h? It's probably right here. -5, -2. Does that make sense? The fact that they're both negative, by the way, even without looking at the graph, is a good sign, isn't it? Because we know the third quadrant is where x's and y's are both negative. So it says -5, -2, 1, 2, 3, 4, 5, and then down 2. Yep. So this, even though it doesn't really say it there, is vector h in component form. So this is an identical vector to this, which is an identical vector to this. So there's two ways to write vectors, one using their components and one using magnitude angle form. And each have their uses and places where they're more appropriate.